All right, let's dive into something pretty fascinating. How we can take a general-purpose AI, one that knows a little bit about everything, and transform it into a highly specialized expert. So think about the large language models we use all the time. They're incredibly powerful, right? They've basically ingested the entire internet, which gives them this huge, broad base of knowledge. But that very strength can sometimes be a weakness, especially when you don't need a jack of all trades, you need a master of one. And this really gets to the heart of what we call the generalist's dilemma. For all their power, these models have some real limitations when it comes to deep, focused expertise. Now, don't get me wrong, pre-trained models are absolute marvels. They have a rock-solid understanding of language, of context, and they can generate text that's almost indistinguishable from a human's. They are incredibly versatile tools for general tasks. But here's where we hit the wall. A general model's broad knowledge just doesn't quite cut it when you're dealing with the niche jargon in medicine or the super specific nuances of legal contracts, or even a company's own internal data. It can give you a decent answer, sure, but it's not going to have the precision of a real expert. And that's exactly where fine-tuning comes into the picture. It's the bridge that connects these powerful generalist models with the very specific needs of a specialized application. So what is fine-tuning, really? Well, you can think of it as taking a model that's already been trained and just slightly tweaking its internal wiring, its parameters, using a much smaller, focused dataset. The key here is that we're adapting an existing intelligence, not trying to build a new one from the ground up. Yeah, this is probably the best way to think about it. You're taking a model that knows a little bit about everything, and you're training it to become a true master of one particular skill. It's a really powerful concept. So, how does this process actually work? Let's walk through how you actually teach this expert its new specialty. The process is actually pretty straightforward. You start with that massive pre-trained model as your foundation. Then, you introduce your specialized data, say a collection of medical research papers or legal documents. The model then continues its training, but this time, it's just adjusting its existing knowledge to fit this new information, which results in a brand new specialized model. And this is a really crucial point. You do not need another internet-sized data set for this to work. All the heavy lifting, learning grammar, context, how language works, that's already done. You are just guiding the model on the finer points, the specific nuances of your field, and you can do that with a much, much smaller set of data. And that efficiency is the real game changer here. It's what makes fine-tuning such an accessible and incredibly powerful technique for so many people. Now, the magic behind all this efficiency has a name. It's called transfer learning. This is a core concept in machine learning where you take the knowledge gained from one task and you reuse it as a starting point for another related task. You're basically leveraging all that prior knowledge. I love this analogy because it's so perfect. If you already know how to play the piano, you get music theory, you get harmony, you get rhythm. Learning to play the organ isn't like starting from scratch. You're just transferring your skills to a new instrument. It is the exact same principle with these AI models. And when you look at the comparison, the difference is just staggering. Training a huge model from the ground up requires an unbelievable amount of computing power, massive data sets, and just a ton of time. Fine-tuning, on the other hand, is orders of magnitude more efficient. It really democratizes custom AI, making it accessible to pretty much everyone. But, of course, it's not a silver bullet. To get the full picture, we have to talk about some of the potential pitfalls. You have to approach fine-tuning with a bit of caution. The number one risk you run into is something called overfitting. This is what happens when the model learns your specific training data a little too well. It basically starts to memorize it, and then it loses its ability to generalize to new information it hasn't seen before. You know, it's just like cramming for a test by memorizing the answers on a study guide. If the questions on the actual exam are phrased even a little bit differently, you're toast, because you never actually learned the concepts. That's exactly what overfitting is, and it's why having a high-quality, diverse dataset is so important. There's also a bit of a trade-off you need to be aware of. As you turn your model into a superstar at, say, legal document analysis, it might get a little worse at other things, like writing song lyrics. That's just a natural consequence of specialization. So at the end of the day, successful fine-tuning isn't a one-size-fits-all thing. It absolutely requires a clean, well-curated data set to avoid that overfitting problem we talked about, and it takes some experimentation to really find the perfect balance for what you're trying to do. But really, fine-tuning is all about leverage. You're starting with this incredibly useful general-purpose tool, and you're sharpening it to become exceptionally good at the one specific job you need it to do, all for a fraction of the cost of starting over. And that's really the main takeaway here. Fine-tuning isn't just about making AI smarter in some general sense. It's about making it wiser. It's about giving it the specific, nuanced knowledge it needs to be truly valuable in the unique worlds we all live and work in.